Welcome, ladies and gentlemen, to another episode of Listening to the Wind, IWSA's weekly interview series. And I'm delighted to welcome two friends from Israel, from NAYAM Wings. And I'll just quickly introduce them both. We have Mr. Amnon Asscher, founder, inventor, CEO, co-CEO, and CTO of NAYAM Wings Limited. He's an experienced engineer in aerospace and shipping industry and program. And he has 10 years of R&D experience with asymmetric rigid wings. And possibly the most important, he's an experienced sailor too. So welcome, Amnon.
Welcome, thank you very much.
And sitting with Amnon is his colleague, Saar Carmeli, who's co-founder and co-CEO of NAYAM Wings. He's a retired Navy captain with nearly 3 decades of service and currently is a strategic and business development consultant with government and the private sector. Welcome, Saar.
Welcome, and thank you very much for having us here.
Oh, no, it's my pleasure. So I think we're in very good hands for a very interesting interview today. And without further ado, I'm going to hand over to Saar, who's going to give us a presentation on the NAYAM Wings concept. And I'll see you on the other side.
Thank you very much, Gavin. So, NAYAM Wings, established in 2016, and we regrouped at 2020. We like the saint of William Arthur Ward, is American poet, who said that the pessimist complains about the wind, the optimist expects the wind to change, but the realist is adjusting the sails, and this is just what we're doing in NAYAM Wings. We are a small company, we're a startup, but alongside with the business that we want to succeed, we are looking, we're dedicated for a cleaner planet that we want to contribute to. This is a goal of us. Ships contribute to air pollution a lot. There's about 51,000 ships globally, and this count is not increasing, but the dead weight of the ships is increasing substantially, and the fuel consumption is increasing alongside with it, and of course the pollution. Around 3.5 of the entire greenhouse emissions coming from ships only in Europe. And if we don't deal with that, the situation will be very bad in a few years, as you can see in the left side corner. It brings new opportunities. Shipping companies already changing to higher grade fuels, converting some of the engines and using other means of thrust, but all these solutions are time sensitive, they're not giving the right impact, and the shipping charges are exceeding. We all know, we dealt with a container 2 years ago from China, it cost $2,000. Today, they're speaking about $15,000. There's a number of reasons for that, but of course, fuel is a major factor. We want to go, say, back to the future. The oldest solution is the newest one. Almost all of the goods can travel by sea and delivered by sea, and we have everywhere a free resource, which is the wind. We must use it. We think it's a present that we just neglected for the last decade. NAYAM Wings in this field brings, we think, a new category of rigid wing sails, asymmetric sails that are unique technology. When we speak about wind propulsion, there is a physical barrier. We can't install a huge wing without thinking about the transverse force it produces. And this transverse force caused the ship to heel aside. And when we speak about the height of the mast, we think about the heeling force it produces on the ship. And we in NAYAM Wings dealt with that problem. What is our breakthrough? We took an airplane shape of a wing and positioned it on a ship. This position of when the plane is landing, the wings has the position of the flap and the slat that produces a very high lift force. When we use an asymmetric three-element wing, we needed to bring up a patent to take the wing from side to side to roll it, and that is just we did. What is our advantages? We control the heeling of the ship by rolling the wing. Actually, in some ships, we contribute to the stability of the ship, and it will shake less than it rotates right now. We have a tremendous two-dimensional lift-to-drag ratio of 56:1. And then in 3-dimension, it's also very, very high ratio. We are minimizing the transverse force, and because of that, we maximize the fuel consumption reduction, and we expect an ROI on our system of 5 years, even less. The innovation that we made, we managed to design a super efficient wing. We tested it with CFD simulations, and we calculated that we can reduce fuel consumption and emissions by 15 to 25% without changing the speed. This is very important because if you take 1 knot out of a 50,000 ton ship, you reduce 1 knot, you can save about 2,000 megawatts. But usually shipping companies doesn't do that because they have to act on a time schedule, a very strict timetable. And all our calculations is without changing the speed of the ship. If a company would like to reduce its speed, we can reach much higher percentage, 50% or more, of course, if we reduce the speed even to 10 knots. But we're speaking about regular ship speed. This is a small
animation.
Yeah, small animation about how it's going to act. As you see, in this scenario, there are 6 wings. Most of the ship will need 4 wings. And when the ship is turning and the wind is changing side, you can see that the wings is automatically adjusting itself. And it's important to say that our system is fully automatic, and the sailors doesn't need to know almost anything to operate it. This is a demonstration of the potential fuel consumption reduction between 3 different systems. One is NAYAM, and the other 2 is 2 different known technologies, not the companies. We tested the technologies. As you can see in the right corner here, what we did is we leveled the transverse force, so all technologies will have the same transverse force acting on the ship. As I said before, this is the actual barrier. So for each of these systems, the ship will heel the same. And in this scenario, it's about 400,000 newtons. For this side force, these are the element dimensions of each technology. NAYAM Wings is 30 meters on 6 meter width and 4 wings. The other technology is 27 meters on 3.5 and 4 wings or elements. And the other one is 36 meters, 6 meter wide and 12 elements upon a ship to produce the same transverse force as I said before. And what we will see in the middle is the actual saving that is calculated. The average reduction is about 20% of NAYAM Wings. And the average saving per year for this particular ship with engine power of 5,000 megawatts and wind speed of average of 8 knots, as you can 60 knots, sorry, 8 meters per second. As you can see, this is a regular figures. So NAYAM Wings brings the 20% of average saving, and the other technologies less than that. And because of that, our ROI in this scenario, the ROI is 3.8. And there are, as I said, several scenarios. It depends on the ship, how big it is, and the maximum size of system it can contain in a safe position. The cost is, I think, it's relatively the same between all manufacturers of rigid wing sails of fiber carbon. It's expensive material. The systems of NAYAM Wings will cost between $1 to $3 million per ship for 2 to 6 wings per ship. Based on 15 to 25% fuel saving, we expect less than 5 years of ROI. Of course, the bigger the ship, you can save a little bit less percentage, but it's a lot of fuel per day. We will offer for big companies a leasing model that will lower the entry barrier for about 33% of the system cost. And the rest of the money will, how someone said about it, like pay as you save. When you save, you can pay about for the system. And we think that in this model, it will be easier for shipping companies to purchase such systems. About the market. So there's about 51,000 ships globally. Out of them, if we start with retrofit, there are around 14,000 ships that are relevant for wind propulsion retrofit. And each year there are around 1,500 new ships that are relevant for wind propulsion technology. We believe that in a few years, every ship will install some wind assistant propulsion, because it's the reasonable thing to do. There's a prediction of about between 3,700 to 10,000 wind propulsion system by 2030 by UT Delft, and the UK government sees an increase in investment in this area. And of course, due to IMO 2020 regulation, we think this market will go higher substantially. I think that the IWSA predicts this also in your site, Gavin. What we have achieved by now, as you can see, this is Amnon sailing with the first medium-sized prototype. It's a 9-meter wing. This is a relatively heavy wing, but performed beautifully at sea and gave a lot of thrust. So 8 meters, sorry. So it was a very successful trials. We applied for the patent in Europe. We are now in the national stage. We believe we will reach it soon. And our company was awarded a grant from the Energy Ministry of the State of Israel, and our development is now under their wings. This is what we would like we wanted to present to you. We truly believe that together we are saving the planet with the wind propulsion. Thank you very much.
Thank you, Saar. That was a very, very interesting piece. If you could just close down your share screen, that'd be great, and then we'll all come back onto the screen.
Sorry.
No, that's fine. No, really interesting, and you know, maybe I'm the optimist, and you guys are the realists. So it's always a good mix, I think. Really, I mean, it was really good to see the economics that you were talking about there, and I noticed you're actually being very conservative with the fuel price there at around $400, which I think is at present that's around about where HFO is or IFO 380, but even with the very low sulfur fuel, that's a good $50 higher than that already, and MGO $100 higher. So I think I agree with you. Those ROIs are definitely going to be coming down, and I think we've seen across the sector as well, as units are produced, the costs of those units will be coming down as well. So it's a double benefit there. I could talk all day about that sailing that you were doing there, Amnon, as well. It looked like you were having fun. Yes. Development and having fun. But I'd just like to ask you, you talked about the markets there, and you mentioned the 51,000 vessels and the UK government projections. I think they were looking at around 40 to 45% penetration of that market by 2050. Which of the markets do you see as the kind of low-hanging fruit, the main ones for your technology?
Okay.
This will be all flat deck ships, all types of flat deck ships, and even I would say in all sizes. It could be bulk carriers, it could be tankers, it could be any kind of general cargo with flat deck. So we can penetrate a very big percentage of the entire fleet.
Right. And have you looked at any kind of adaptation for container sector? Because obviously that's always a challenge with limited.
Yeah, we do not even try at the moment to go for container ships, mainly because there's no place on deck to put wind propulsion devices. Mm-hmm. And if we do, it will have to be above the containers, and this is too high, and it will produce too high healing moment.
Yeah, indeed. I get that. And it was interesting you were talking about that healing moment, and that's always a challenge. I mean, with Flettner rotors, it's not such a big issue because of the rotational effect of that. And with some of the off deck ones, not such a big issue. But obviously, ballast is one of the ways to control that. But it's interesting that you've very much focused on that area with your design. So,
we know that when a strong thrust is produced, mm-hmm. it also produces a strong side force in certain kind of winds. So it affects all systems. our system has the lower transverse force when you compare it to forward thrust.
Yeah, no, indeed, and I think that's a really interesting way of attacking this. Yeah.
And besides, I'll show you now. Here we have, you see, maybe you see a 3D model.
Yes, yeah.
Of the wing. So once we sail to the right direction and the wing is adjusted to the right angle of attack, once in that kind of, well, it will be actually like this, okay? If we sail forward and we position the wing in the right direction, it will produce a heating moment this side. What we do, what nobody else can do, is we rotate the wing and then we lower the healing moment. So we are the only technology that can control the amount of healing moment.
That's very, very interesting, very interesting. And I was going to ask you, we're looking to get these technologies into market, and we've had these discussions. I have these discussions with all members. What are the main barriers that you're finding to bringing your technology into market?
Okay, I'll tell you, Gavin, the shipping world is very conservative, and it doesn't like changes. And the other thing is this kind of technologies, the development is very expensive. So the two things is some kind of a barrier, but we see in the last, I think, decade that it changes. There is a change here. And when regulation will become stronger upon pollution, shipping companies will have to find solutions to reduce this. So they find several immediate solutions with cleaner fuel and everything, but they will need to reduce the cost of the shipping. And this is exactly where we come in.
Yeah, I would agree with you that in general, the industry is conservative, and you have things like safety first and having tested certified systems. But I have to say I've seen the industry move incredibly quickly over the last couple of years to embrace, or at least to be talking about embracing, new technologies and new fuels. We're still not seeing the scale or the uptake, but I think you're coming into the market at just the right time.
We believe so too. Yes,
absolutely.
We feel the change. Yes.
Yeah, no, indeed, and I can't wait to see the first installations of the NAYAM wing. But there are a limited number of demonstrators and technologies out there. I mean, we've got about 11 ships in operation at the moment with a variety of different systems. Growing interest from shipping companies. I get phone calls every day, pretty much from companies asking what's happening and where can they get additional information. But if I'm a shipping company, how do I start the process? How would if I wanted to have a NAYAM Wings system on my ship today or in the next few months, how would I start that process?
All right. So I think that the first thing that I would like to check is to find the right system with the shortest ROI for my means. I want to pay money and I want to receive it the fastest way that I can. The other thing is to find out the real fuel saving upon my fleet. I have several ships with the dead weight of such and such, and I want to calculate. I want NAYAM Wings to calculate my savings upon these ships. And the next step is to choose a route or several routes of my shipping company that I can give the NAYAM the average winds and directions. And I want to calculate how the system will act upon the certain ship and a certain route. And I want to find out that. If I am satisfied with the calculations and I want to check it even with an outside examination, it's okay. I need to invest in the chosen company because, of course, we haven't developed yet the full-scale prototype, the fully automated, but we are on our way. So if a big company will invest a relatively small amount of money to help us develop the full-scale prototype, we can reach about 1 to 3 prototype systems that they can put on ships and to check it if it really provides the actual saving that we speak about. If we prove this right, this shipping company will be the first one to have a wide installation on every ship. Let's say they have 50 ships, so they can install it. Let's say about 40 out of the 50 ships that they will install it upon most of the fleet, because if some of them is container ships, so it's not relevant at this time.
So you're looking for a collaboration with ship owners that can see the benefits of this going forward and want to work with you, not just purchasing a finished product, but want to work with you to optimize that system and then be able to roll that out across that fleet. Yep.
Our mind is focused on producing the best saving for the shipping company. So we would like to continue working on that and not just sell our company to another company. This is not our interest. And I think that working together, we can spread the word worldwide. And the company that will do it with us, of course, will have the control and the most benefits out of it.
Sure. No, absolutely. That makes a lot of sense. Now, I'm gonna step out a little bit out of your project, and we're just going to talk a little bit about the wider kind of wind propulsion and where that sits in this whole decarbonization of shipping drive, if you like. We have huge amount of discussion around alternative fuels, zero emissions, etc. The direct use of wind is often just kind of bolted on the side and say, "Oh, we could do a bit of wind." Well, is that really the way forward for shipping, or do we need to be bringing wind propulsion into the heart of this discussion and into the heart of those pathways?
I think that wind propulsion will reduce costs to any other kind of alternative fuels. So if by today, a big part of, or maybe even the majority of shipping companies are looking first for alternative fuels with less carbonization, they will always benefit from the wind propulsion together with their alternative fuels, because we will save costs by between, let's say, 15 to 25%, which is huge amount of money. That is one thing. The other thing, once we can reduce transportation costs, it will actually reduce the goods costs. So it might affect the entire world, the entire economy of the world, because this is really a very big point.
Yeah, and I noticed, I mean, you highlighted the fact that it's something that I talk to quite often, that 15 to 25% is calculated on a motor vessel operational profile.
Right.
And you mentioned specifically one issue that it doesn't include is the reduction in speed. And Saar, you were very clear about that. You know, when we adjust speed, maybe weather routing for better wind conditions, a number of other factors, then those numbers start increasing pretty dramatically. I mean, you had I think a number there, 50% plus. Right. That is extraordinary. And I think that the industry doesn't really appreciate that when you reduce speed, you save fuel. would you also increase that percentage of energy that can be delivered from wind system?
Well, I believe that the market forces are they are the strongest, and they control the path. So if goods cost must be reduced by market forces, then they can consider to reduce the speed of the ships, to make the longer roads, and then the market will adjust itself. But we work under all of us under the market laws, and they are the strongest. So this will influence the speed of the ships, not otherwise.
Yeah, no, I agree, and I think one of those issues is getting the technology into the market so we can prove those business models, and I think that's absolutely true. And this brings me on to probably the last point that we're going to have in the discussion, is I agree that those market drivers are going to be substantial, and they're going to be really, that they will finish the job. But in the meantime, we've got incredibly cheap fossil fuel at the moment. It's untaxed, there's no carbon price, etc. So regulation has kind of kept up the pressure, and obviously the pressure. We also have the climate change issues have been quite big as well. But with there are a set of measures that are being proposed at the moment. We have the EEXI. We maybe have changes to EEDI coming through, but EEXI, CII, the carbon intensity issues, and also, just for example, the inclusion of shipping into the EU emissions. Which of these kind of if you like, non-market drivers, these regulatory drivers, which ones are going to be the most impactful for the uptake of propulsion? Amnon.
I think all of them together. Yeah,
that's the easy answer. Yeah. Yes.
Look, we have a fantastic EEDI, our technology, which is I think maybe the highest.
Mm-hmm.
Regulations will work for us, of course.
Maybe I'll answer in another way. When we look at what happened in Israel in the past 20 years, factories that were polluting the environment had fines. They got fines. So their product, if they are a monopoly, the product just increased its price, and the actual fine was paid by the customers. But in the last 20 years, the government made some changes and gave strong regulations, and factory managers can go to jail when they pollute the environment. And this was the most effective thing. So strong regulations that act upon the captains of the ships. You can't sail with a ship and pollute the area for another country. You can't go to another country and spoil fuel or pollute the environment, the air, to the residents. And this is I think that this kind of regulations, it's even stronger than what you said. They have to be very strict about it. You can't pollute the air anymore. This planet can't suffer it. So if this regulation will act upon not only the ship owners, but also the operators, the captains of the ships, they will not want to go to jail or to suffer from personal fines about it. So I think this kind of regulation will accelerate the process of other technologies like wind propulsion, which we believe is the cleanest and the cheapest one.
Yeah, I mean, we've certainly seen that liability in other regulations that are out there that you know, for operations. I'm not sure if we would see it in the near term for pollution, but that doesn't necessarily mean it's not going to happen.
Yeah.
But I think, yeah, I agree that, you know, that regulatory frame drives, you know, where the market fails, it drives better market behavior. And then that allows the market to take over when it's level playing field, as we hear many times. Gentlemen, that was a very interesting discussion. I'm going to move on to now quick fire Q&A. So what I'd like is I'm going to ask 4 or 5 questions. You've got a one line answer. So either of you can jump in and answer this. But the first one, I'm going to ask you, I'd like both of you to answer. So a really short question, really short answer. This is not an easy field to be working in. It has a long lead time. There's a lot of challenges. How did you get into this person?
Well, I spoke with Amnon, and I was just going up in flames when I saw the technology he developed.
Amnon is your inspiration.
Yeah, Amnon is my inspiration. Exactly.
And who is your inspiration, Amnon?
Well, I was teaching gifted kids about aerodynamics of regular sailings about 10 years ago. And then as an aeronautical engineer, I all of a sudden thought, well, why using soft sails instead of rigid wing like aircrafts? And this is when I started to roll the idea on and on. And then I came, of course, immediately to the symmetric barrier of all other wing sail technologies except for us.
Okay.
And then I was going to the beach and looking at kites. And then I realized that kite is actually an asymmetric wing that moves from one side to the other side. And then I started to go on, and this is when the rolling of the wing idea came to my mind.
So it was kids, beaches, and kites.
Yeah.
Fantastic. And that actually asked my second question, so I'm going to leave that aside, what inspired the NAYAM Wing. So I think you've already answered that. Very quickly, what do you think it's going to be retrofits or new builds will be the real driver for wind propulsion?
Okay.
So one word answer, maybe.
Yeah, the first thing will be retrofit, and the second will be new build vessels. All new vessels will be needing this kind of systems.
Okay. What are the next steps for NAYAM Wings? Very quickly. Don't go too into it, but I'm expecting that you've got expansion plans. What are your next steps?
Our technology next steps is we have already started to build another small proof of concept boat where we will try the complete automatic control system on the wing. And then we will go again to a 9-meter size proof of concept with a fully automatic wing with 3-element airfoil, which will be exactly what we will have on big ships. And this will conduct very precise test sails with all the measurements, and we will be sure what will be the final results on big ships.
Right, so some really exciting times for the engineers.
Yeah.
And after that, the sales team really kicks in, yeah?
Yeah.
Absolutely, yeah, that's brilliant. I'm going to ask a question that I ask all of my interview subjects. Have you calculated the carbon footprint of your system yet?
This is in process. When we do it now, we have to think about how many ships we can reach. But we believe that when we will reach a wide spread of our system in the entire fleet, a lot of tons each day will be reduced by our system.
and the embedded energy, you know, the energy that's the carbon that's used to actually produce the system as well. Are you planning to calculate that as well?
Of course, we think that the fiber carbon manufacturing, it's not that affecting the environment, and we actually started to think about solutions of what to do with the wings at the end of service. And this is something that we think about right now, although it will be affected about 15 years from now.
Yeah, no, absolutely. That circular economy is very important. Yeah.
Yeah, even more than 50 years, you said, right?
Oh, for a wing, I think it's about 15 years when you see make an overall to the system. About 15 years.
Okay. Last question I'm going to ask you, and it sounds a bit like a job interview. What is the most difficult question that you've been asked about your system over the last few years?
People said to us, you have presented an amazing technology. How come it's not yet installed on vessels? So we say together, when we regrouped with Avishai Parker, the third partner of us, we're working together only for 7 months now. We believe that in 1 or 2 years, we will reach this goal. And
you've made a lot of progress in that time, I think.
Yes,
yeah.
There are some very big players in the cycle of manufacturing such systems that are contacting us, and they are very interested in going together with us.
Yeah.
Excellent, excellent. Well, gentlemen, we don't have any more time for those questions, but thank you for that. I'm going to give you just 1 minute to give the audience a kind of summary or a takeaway statement from either of you or from both of you. That's absolutely fine. So this is your chance to kind of summarize what NAYAM Wings is all about and give them a takeaway. So whoever would like to take that on.
I will start. I would suggest any shipping company or anyone who is interested in wind propulsion that they will investigate our performances and compare them to other technologies, and then let them decide which technology they want to have on their ships.
And Saar, would you like to add anything?
I couldn't say it better. I would like them to test us.
Fantastic. Well, look, gentlemen, really appreciate you giving your time today. And I know that Amnon and Saar will be more than happy to answer any questions by email or by phone. And of course, if the audience has any questions relating to the wider wind propulsion world, then I'm always available to answer those questions too. So, thank you very much, Amnon and Saar. Really appreciate your time today.
Thank you very much, Gavin.
And thank you very much to all of you listening or watching this podcast and this interview. Listening to the Winds will be back next week with another interview. So signing off, fair winds to everyone, and please stay safe and well. Goodbye.
Thank you very much. Bye-bye.